Sorry for interrupting.
I know. So these guys, whoever Harris, you don't write in the message that I'm not recording. Just say it, interrupt and say I'm not recording so that I can record.
Okay, sir. Okay,
yes.
Sir.
Always when I'm not, I will change the online version so that you will automatically record. Yeah, just interrupt if I forget to record. So all information about a single instance is called data point observation or instance. We also discuss about what is called training set and validation set. A training set is where you divide. If you have a machine learning data, we divide our data set into two. At the basic level, we come to some other part, which is called training set. You train your machine learning on some sample of the data. But when you train your machine learning, how do you evaluate whether the machine learning works very well? That it can predict, because one of the essence of machine learning is just for prediction. So then we divide out. If we have, for example, 100 samples in our data set, then we can train on 80% and now test or validate our algorithm using called validation set. We also discuss about what is called predict sets, independent. All this one mean the same thing. So given this data, these are the predictors of whether something is setosa vesicular. What do you mean by predictors? Because these are the terms that contribute to tell whether a flower is setosa or which class. These are called predictors or features. In machine learning, we call them features. But here you can see how many features do we have? Who can tell me how many features here do we have?
We have 4 features, sir.
Okay, exactly. We have 4 features, but mind you, here just is done an example. We give 4 features, and all these 4 features are relevant to actually the predictive tags of our class, because the pattern with. But sometimes you may have a lot of features like 10, 20, 50, 60. Does that mean you are going to use all the features to do in machine learning? Who can answer this question? I said, here we have only 4 features, and we can see that all these features are relevant to predict whether a plant is setosa or which class. They are relevant. But in the real world, some features, you may be given some data, and some features may not be relevant for prediction. Do you think, what can we do with such features? Who can tell us?
We drop them.
We drop them. So in machine learning, there is some what we call feature engineering or feature selection. There's even books, in fact, that discuss feature engineering or feature selection. So for example, here, let me share the one book here, this by Max Kuhn, which is the author of Applied Predictive Modeling, Feature Engineering and Selection. This means that if you have large amount of features, not all features will be useful for predictive purpose. It means you need to find a way to select useful feature that has some kind of predictive power in them. So for example, there are many books for that. So yeah, so this is just to give you an idea, but we'll come to step by step, just we're giving stuff. Then there is what is called outcome or independent bias. So this is outcome. So given these features or predictive features, this class is called outcome here. Okay, given somebody is having headache, somebody is vomiting, somebody is whatsoever, what is happening to him? Maybe we can say, okay, he's suffering from so-so and so-so. That is called class, or that is called the outcome. So here is called outcome class. So we have different names: outcome, dependent variable, target, or class. You can see all these names, but when you see all this name, then you should know what they mean. We discuss about continuous data. When we have continuous data is when we have a value, continuous value. For example, here 5.1, all these values are continuous data. But we have what is called another thing, categorical data. So this class, because we are predicting 3 classes, Setosica, Basilica, is 3 classes, so that is called categorical variables. So for example, we have red, blue, and something like that. These are cool. Then the last one we discuss what is called model building. So when we talk about a machine learning model building, model training, or parameter estimation, all this means the process of determining the value of model in equation. We discuss this, the process of fitting the data into model. That is called model building. So these are some of the features we discussed last week, and Yeah, so you see, these are few steps in machine learning. The next one we said, after you print the problem, get the data, process the data, and model the data. So what do you mean by process the data? When you get your data, sometimes the data you'll get, they are not in good shape. You may have missing values. You have some kind of features that are not actually part of predictive power. You need to remove them. You can do a lot of things. That is called processing the data, one step. So processing the data involves many steps. So we divide here process data exploration. So when you are given a data, what you need to do is first explore the data. Try to understand how the data looks like. For example, here we say, okay, just let's see how the data looks like. Okay, you just observe the data. All right, I see it has these features and stuff like that. Then you can also find how many data set do you have. Okay, right, I have 150 samples. Just observe the data and see what are the columns. You can find the columns here like this. Okay, I have this kind of columns. These are the features. And also you can find the target variable, target also, which we discuss here. So you can see the target. These are the class Setosa, Vesicular, Virginica, and all of them you can see they are 50-50, right? So this is, you can also run this info, which is also another function to look at the detailed data. All this, there is detailed data exploration for your data. This is another huge steps in machine learning to explore the data, just to show you how it is. This is also another function called describe that you can call in your data to see some of the count and stuff like that about data. But also one of the important steps to do in your machine learning is to visualize your data. So when you're given the data, visualize the data and see how it looks. Can it support your machine learning stuff? So this data, we visualize it and we see that, okay, this you can see this is iris, setosa, vesicular. We can see that the data is separated, linearly separated. So this means that our machine learning will be able to separate the data into different classes. Can you see that? Yeah. So these are some of the steps we then the next one we discuss is prepare the data for training. So what we mean by prepare the data for training is divide your data into what we call training set and test set, right? How can we divide your data into training set? So we said we cannot train our machine learning model on the whole data set we are given. What we can do when we have our data is to actually divide the data sets into two, training set and test set. Why we cannot train the whole machine learning in the whole training data? Because the machine learning algorithm is so clever that it can memorize the whole example. Okay, if you say this is an example that this person has headache, he has also vomited, and you say this is what is happening to him, and you give us some instances. All the data, when you train on machine learning, the machine learning is so clever, it can memorize. And when you give an example, it can predict the something. So you don't need to train the machine learning and also test, evaluate in it. So to evaluate machine learning data set, we said you need to have a different data set called test data or test set or hold outside. This is the whole name of the training data. So you divide your data, if you give a machine learning data set, into two sets. The first one at the basic level is called training data, right? It's called training set or training data. Then the one you test your machine is called test set or hold out. That is what we divide our machine learning data set. So now let's look at how we can divide our machine learning data set that we are working on. So last week we stopped here. We didn't see how we can divide the data set. We see a little, but we have not seen how we can do that. So now how can you divide your data set? So given like 100 example of your data set, do you just divide your data set into like 50, 70 or some stuff like that? Yeah, there is some kind of gold standard that people use. You can divide your data set maybe into 75 to be training set and 25 to be test set, or 80 to be training set and 20 to be test set. Fortunately, you don't even need to divide it anyhow, because like if you have your training data, for example here, this number 1, number 2, number 3, and you just divide it into here, for example, this data may be sequential, and you do not actually divide the data into equal division for the training. So Scikit-Learn provide us with a function that allow us to divide the data set. And before even we divide the data set, Scikit-Learn allow us to even shuffle the data. To shuffle the data allow us to make the data set not a kind of way in which we do the division into equal division. Now, so this is an example. Given your data, how Scikit-Learn divide your data, given an original data frame, how can you divide your data? So you divide your data into 4 classes. We have what we call train X. So in Scikit-Learn, they call X, the big capital X, as training data. Futures, called future, or future, or independent variable, and your Y is called target variable. So, and Y here you can see is small letter, but X is capital letter. So we divide our data set. So for example, this section, the first one here is called X train, and here is a Y train. So you train your machine learning model first on this part, you train your model, tell the machine learning, okay, this is the answer, because this is where what we are doing is supervise. You say, okay, this is a person, he has a headache, he is vomiting, he is so, all this are the future, and you say, okay, this is what is happening to that person. You give it to another instance, this is Mr. B, he is vomiting, he's diarrhea, he is so, this is a disease that is affecting him. So this is the answer, this is the futures, right? And this is a test set. Also, these are example of the futures. These are the answer. Futures, answers. Futures, answers. Any question before we continue? Yeah. Any question? So this means that what I mean by this is our data set, right? I just head of the data set. So this means that this whole data set will be divided into 4 division. So let's look at the whole data set here. You can see iris. Yeah, so this we can see that the data says that this is 0, this is 149. It means our data set is 150, right? Then it means we need to divide our data set maybe into 180, 130 to be training set, and 20 to be test set. Just an example. This means that we need to divide like some section, but as you can see, we don't need to divide the data set. We just take this section like 100, because if we divide this, it means all the setosa, because we arrange the setosa example comes first. From 0 to 50 are all setosa. From 51 to 100 are all vesicula. From 100 to 150 are all beginica. So you see, if we divide our data set sequentially from 1 to 100 to be training set, that it means the training set will all be setosa and vesicula, cannot beginica. So this means that we need to shuffle the data set before we do even division. Does that make sense? Any question? Right. So we need to shuffle the data set. So how can we shuffle the data set? Scikit-Learn, as I said, give us a function that allows us to shuffle our data set. But how do you do that? So before we do the division here, we do division. We say, okay, this is sepal length, this is value of sepal length, sepal width, petal length. This is the class setosa. This is the class. Now we need to divide it, and this comes to before we even divide the data set. Look at it. Before we even divide the data, it means you can see the original data frame, the whole futures and target, they are all in single data frame, right? But before we do the division, we need to divide. Can you see? Can you see this? We need to divide the futures, separate the futures and the what? Trend and the target. We need to separate the future into a separate data frame, and we need to separate this one, because you can see here they are all together like this one. Can you see? We have a single data frame that contain the futures and the what class, a single data frame. This means that before we even divide, we need to separate this data frame with one with futures and one with the target. So that is what we need to do next here. So let us train the data. So you can see here, I need to have what is called X, which is this. Can you see? Train X here, X, and this is called Y. So it means here I will divide, I will pull out this column, this column, this column, this column. I will pull them out from this data frame. How can I pull that out? That is what we discussed in our previous session of Python learning in pandas, we can do what is called drop function. Drop function will drop this. You can specify the column you want to drop in pandas, and axis specify you are dropping a column. So here when we say x iris, because iris is the name of the data, then you call this function dot drop which class you are dropping, which column you are dropping. The column you are dropping is called class. So when we run this, it means we are selecting only this column. So also when you want to select a single column from pandas, what you can do is call the data set and subset it. This is how you can select a single column in data frame. And we already seen this in our session where we do learn pandas. So let's look at what is X now. I run this already now. Okay, let me do it. Yep. So can you see now we remove only these features into a single data frame. Can you see that? Now let's look at what is our Y. Can you see our Y now is this? So this means that now before we do the division, we divide our data into train and test. So I divide it. Now after I divide the two, then I can say, okay, divide this one into two. Also divide this one into two. Can you see that? Now Scikit-Learn comes with a single function that you give it the whole data frame. If you give it the whole data frame, then tell the function divide the data into 75% to 70% to be trained, tested to be 20%. You can tell the function. So we don't need to go to whole steps like a long step. Okay, first divide this data into two, then divide it like this. No, we will take the whole data frame. Can you see that? And now after this division, we give it to Scikit-Learn. After that, then Scikit-Learn, we divide the data set. Let's look at it. So now we have our futures column and we have our target column. So let's look at how we can do that. So in Scikit-Learn, we have a function called train test split from the name. Train test split. But before we look at Scikit-Learn, okay, this is NumPy we import because Scikit-Learn was built on NumPy, then we need to import all this stuff. So you can see here, we import a module called train test split from Scikit-Learn. So from, I believe from Python, we know how to do this. So what is this telling us here? That train test split is a function under what? Who can explain what is the meaning of this? Who can explain us what is the meaning of this line? From sklearn.module selection import train test. Who can explain this line? Anyone can explain us?
Okay.
Mm-hmm.
Yes, we have a module, Scikit-Learn. So we import a class called train test split.
Okay.
That is it.
So what is, okay, we have Scikit-Learn and we have model selection. Are they, what is model selection? What is Scikit-Learn?
So the Scikit-Learn is a module.
Okay, what is model selection itself?
Package. Module selection is an object.
Okay, are you sure?
I think Scikit-Learn is the package.
Okay.
Model selection is a module.
Okay, what
and
is
then test split is a function in that module.
Yes, yes.
Okay, so yeah, so all of us, for those that we did Python, we already did this one, right? So I have something like this to show for those that join us, maybe they have. So there is some structure to import Python package. If you have like a package here, we have something like this, the main package, and inside the package we have what is called sub package, and we have a module inside sub package. So for you to call this module, how can you do that? There are several ways. So you can see here, I have a package inside a package. So what do you mean by package in Python? So a collection of code put together make what is called module, and a collection of module put together makes what is called package. So here I have a package, maybe I have some package and have module. So I want to use the module inside here. So what you can do is you can say these are some ways to call it. So you say one way is say import package. You put the name of the first one here, import package. Then you say dot subpackage, dot subpackage, dot module. So it means you import this one. So you say from the beginning you import this dot this. That is how you read this one. That is one way. Import package dot module dot module. But if you don't want to import everything, another way is you say from package dot subpackage. That is this way. From package dot subpackage import module. So here you are telling this one from here, and this one from this to import to this one. So these are just two way we just a way to import modules in Python. So we discussed this in our Python session where we learn how to use Python. So for those people that just and may be wondering how we can do that, what we mean here is that we have a package Scikit-Learn, and we have a module under Scikit-Learn. So we are importing a function called transet. So you can see when we input this one, it's telling you this is a function, right? Yeah, and when we put here, this is module, here also a module. So here it means we are trying to import a function called trend test split from Scikit-Learn. So let's look at from Scikit-Learn what is trend test split. Trend test split Scikit-Learn. So trend test split, you can see it. So so this is the function from Scikit-Learn, and it has many parameters. One of the parameter is array. So you can see array, but the array, remember in our Python class, do you remember when we have asterisk? It means what? Who can tell us? Here, when we pass array with asterisk to our argument in a function, what does that mean?
It can pick a number of
argument, right? Many arrays. Exactly. So for those that of us like that we did the Python crash course. So when you have an like inside your argument, like you have star that something like this, it means it can take many arrays, not only one, right? So yeah, so something like that. So allow input list numpy some of this. So what about sequence of indexable with the same length? So what this means that this Scikit-Learn the 20, it takes arrays, the first one, but they are of the same length. What do you mean by the same length? What are they? So these should be the, look at them, they should be the trend and test. So let me show you this. They should be the trend. Can you see the first one, which is trend? Remember, we divide our data into X and Y. X is what? Trend. Y is the word? Test, right? So this is our X, remember? This is our X. This is our what? Y. X is the future, Y is the target, right? So in Scikit-Learn function, it means you can specify arrays, not one, but even two. The X, the first one is you pass the trend set. The second one you pass the word test set. But remember, here, if you look at it, here they said sequence of indexable with the same length. What do you mean by the same length? It means that if you look at this one here, the trend says this one is how many do we have? We have 150, but also the Y we have is what? 150. You can see that. So they should be the same length, right? They should be the same length. Can you see my browser?
Yes.
Okay. Yeah. So that is the first function, what you need to pass to trend test split. Can you see trend test split? The second thing you need to pass to trend test split is test size. So you remember, we said we need to divide our data set into what? Trend and test. But how do we divide? How do you want to divide? Do you want this one to be 70%, this one to be 30? So if we said trend set to be 70, then automatically test will be 30. If we say test set is 30, then automatically trend set will be what? 70. It means we don't need to pass two arguments in the function. We can pass only one. whether we can say, okay, the trend is 70, then Scikit-Learn would automatically calculate the test. We don't need to pass the 2. So this means that here you have what is called test size. Can you see that? It has what we call trend size. But test size, all of them, the default is none. This means that if you pass one value, it means the other one, you don't need to pass it. It will be automatically calculated. So, but which kind of value can you specify? You can specify integer. For example, you can say integer 1 to 80. When you specify integer here, for example, if I said my test size is 60, is 40, then what will be now the trend size?
It will be 110.
It will be 110, right?
110, yes.
Something like that. So, that is the test size or plot size. This is the same argument. They can be float or integer. So, but what about if I change this one to be like 0.4? That is float. Now, test size is how much now? I said it's 40%, and the trend size now is what, 60%? Is that right?
Yes.
Okay, so the test size and trend size, you need to pass one, but you can pass all the two, but it's redundancy, right? It's redundant. If you pass one, it can automatically be calculated. So if you read this one, you can see what a lot of what they are saying. All right, let me share. So yeah, so that is that. And also there is random states. What we mean by random state is, as I made mention here, you see, if we just divide the data set into I just take this one, then the whole here, the idea now, if I divide the data sets from 1 to B, I take from 1 to 100, it means the first 1 to 100 will be statistical and vesicular. So it means we need to shuffle the data first. So in that case, before you do the division, we can tell the Scikit-Learn to shuffle the data. So you can say random shuffle. You can put it by default, the shuffle is true. So you don't need to put shuffle here. Shuffle is equals to true. By default is true. But if for some reason you don't want to shuffle your data, you can specify that false, but by default is true. Random state. So for reproducibility, we want to reproduce our work, then we can provide a random state. So random state allow us, like now, when we divide the data set, the next time when we divide, we will have the same sample. Now, now this is the function. So it means what will this function return? The return splitting list of length 2 times length of the array. So what is the length of the array we pass? Is 2. We pass 2 arrays, then 2 by 2 will give us 4. List containing trend test split of input. So this is what we have now. So then you said that here x trend. So here we pass x trend, y test, x test, because we pass x here. Then you have x trend, x test, then y trend, y test. This is how we divide our data. We say, remember, x trend, x test, y trend, this one. Then you divide your data here. You can see. So we have our data set now here. So here you can see we have, so what is happening for those that may not know, in Python, when I say x, comma, y equals to 3 and 2. Who can explain what is the meaning of this in Python?
I think this is multiple assignment.
Yes, multiple assignment. It means x is equal to what?
X is equals to 3 and y is equals to 4.
Can you see x is equals to 3 and y is equals to 4? If you run this, can you see y is equals to 4? So it means we can do like multiple assignment in Python. So this function, this trend test split does multiple assignment. So it will return 4 values. The first one, it will assign it to trend, x trend. The second one, it will assign it to x test. The third one, it will assign it to y trend. The fourth one, it will assign it to y test. So these are the values. So let's look at the value now. If let's run this one, okay. Now we, what is happening? Don't we run something? Okay. Yes. So let's look at X trend. So let's look at it. So this is X trend. Can you see X trend now divided into 90? We have 90 rows. So you can look at it shuffled them by default. You can see this is number 60, this is number 47. You can see it's not serially in order. So we have 90 because we said our trend size is 0.4. 40% is test, but this is 10. Now let's look at the trend S test. What is the X test? S test. So the S test, look at the S test. Yeah, so it's also 60, I think. Yeah, so this is how we divide. So we have now our data set is complete. We have the training set. So let's look at this. So you can see that the X trend and the Y trend, they are all 90 rows, Y trend, because the X trend and Y trend, they must be equal, right? What I mean by this is X trend and Y trend, they must be of equal length. If this is 90, this one will be 90, right? But this one, you will have many columns. So this one, we have single column. That is why here we have X trend. We have the X, is it test? Oh, okay. Here we have six. Okay. Oh, this is it. X trend is 90 because it has how many futures? 4 futures, and Y trend is only 1, right? So we have 90. This is NumPy stuff. How to demonstrate? We have only 1. So this, so we have now our data set is ready. So this is the second step. The step we said we need to do to prepare our data. That is to divide our data set. So now we are ready to start doing some stuff with machine learning. So let's go back and see where we are now. So here we can see we said these are the steps to for us: frame the problem, get the data, proceed, and prepare the data. Now we prepare the data. What next? Now we can do. We need to model the data or train the model. Now this is a step to do machine learning, to train the model of machine learning. So now all these steps that we have seen to divide the data set into there are a lot of other variant how you can do that. But here we are just trying to give the initial picture of what does that mean. So now we need to build the model, our model. Now now we can start building machine learning model. But there are many machine learning models you can choose from. So let's look at some example. Which kind of, so different kind of problems request different kind of machine learning algorithm. So let's look at this one. I think I have right. Okay, let me copy this. All right. Can you see my screen? So you can see here, you see choosing the right estimator or machine learning algorithm. So you can see we have many ways to choose which kind of machine learning algorithm you want to use. So you may be given problem. Then the first question you need to ask yourself, are you going to do classification or regression? Are you going to do a lot of things? So often the hardest part of solving machine learning problem can be finding the right estimator. What we mean by this, find the right algorithm to solve the problem. Different estimators are better suited for different types of data and different problem. Can you see? This is something you need to know. Different estimated, different algorithms are better suited for different types of data. So if your data set is like categorical, then a beta algorithm may be best. If your data set is continuous, then a beta algorithm will be best. We will see all these ones, just giving us an idea. So here is just an idea what how you can do it. So for example, you want to do machine learning problem, you start here. Does your data set greater than 50 samples? If your data set is not then get more data. Don't even start doing training machine learning if your data set is less than 50. But your data set is greater than 50 samples, yes, you have your game. But is your data set categorical? What we mean by categorical, like are you trying to say the data set is, for example, split it into category? For example, this iris data set, yes. If your data set is come here, if it is going to come here, is the data set level? What do you mean by its level? It means an example that we are using here now for this one, the data set is labeled into this is vesicular or whatsoever is labeled. If the data set is labeled, then come here. So is the data set less than 1,000 sample? Yes. If it says come over here, if it is no, go here. So if it is 1,000 sample, you try, for example, we try linear SBC, it doesn't work, then move on. Is it?
So you're not seeing the browser.
Ah, okay. Talk to me like if I'm doing something, yeah. So when I start, can you see the browser now?
Yes.
Okay. Now, what I was saying previously was like the hardest part of machine learning is choosing the right algorithm or estimator, because different estimators or algorithms require different, if you have different kind of data or different kind of problem require different estimators. So this is a flowchart that visualize how you can choose your machine learning. But just for a start, so let's assume you want to do machine learning, train machine learning. What you need to do is just you start like this. Is your data set less than greater than 50, the samples you have? If it is greater than 50, then go this way. If it's not greater than 50, then you need to go back and get more data. You cannot train machine learning model. But the example we are working on now, we have more than 50 sample, right? Then move on. Is your data set category? What do you mean by category? Is it like what the example we have seen, which we have vesicular? Yes, if it is category, don't go this way. If it's not category, go this way. Now, I'm just following an example we are working on. Is your data set level or not? If your data set is level, like the example we have seen, then go this way. Can you see we have 100,000? So do you have 100,000 samples? Yes, example we are following, we have 100,000 samples, then follow this way. If you have more than 100 samples, follow this way. So try a linear SBC estimator. If it doesn't work, then move on. Is your data set text data? If it is, then try KNN. So we didn't try linear SBC now, we just tried the KNN because it's text data. Now, so this is just an example of sheet of how you can use the this stuff, but we come to detail. Now we choose this one. So we
sorry, sir, please. I have a
yes.
question.
Mhm.
Regarding this, our data set, you said our data set is what? Is it less than 100K or greater than? Because are we not having just 150?
Yes, it's less than. That is why we follow this way.
Okay.
It's less than 100,000. That is why we follow this.
Okay, thank you.
Yes, and we choose K-nearest neighbor. Can you see that? We choose K-nearest neighbor, and there are many examples of K-nearest neighbor. So what we are saying here is like we choose a K-nearest neighbor because it's simpler to understand. We'll understand the details there. But K-nearest neighbor, what the algorithm basically does is like giving different kind of point. It is trying to separate, draw a line. So here we say three classification. So here when we draw this line, here is separate one. Here you can see it's something in this region. So you have different three of regions. So what K-nearest neighbor does is like it tried to separate the data point into separate region, some stuff like that. We would see the detail of that, but this is just what it does. So let's train the machine learning model. We have our data set. The first thing you need to do is you need to import the what actually is your classifier. So we say we want to import K-nearest neighbor classifier. So as I showed here, we have different kind of classifier here. So this we have K-nearest neighbor. So K-nearest neighbor can be used for classification and regression. So here we import it here. We import it first from Scikit-Learn. Import K-nearest neighbor. We import it, and the first thing you need to do is to create an object. Yes. So here when we import it, remember how we create object in Python, right? Object oriented. When we import the module here, we import K-nearest neighbor. Then for us to create an object is to call it, and there are many parameters you can pass to the algorithm. So here we say is KNN, pass n neighbors is one. We said, okay, we'll create this one is KNN. So here we create an object called KNN. Any question before we continue? So in Python, for you to create an object is to call your module here, then we call it here, and we said we have KNN. Now this KNN is an object that we created, and here you need to pass separate parameters. Don't worry about these steps. This is something that we will learn, but just showing you how you do how you train the model. So for you to train a model in machine learning, import the classifier that do the classification. The next thing is create an object. So here we create KNN, and you see that this KNN is an object that it contains many information. Oh, we didn't run it, I think. Let me run it. So we run it. Now we create the object. Let's run it here. We see that we create an object now called KNN. So this KNN that now we create an object, this is what we'll use to train the machine learning model and also to do the prediction. The steps, as I repeat, import the classifier, create an object. So here we create an object. Now, what we can do now is just to do training. For you to do train, it just call that object KNN that we do and call this function called fit. This is just this single line. It's what train the machine learning. This single line is what train machine learning model. So let me repeat. For you to train machine learning model, here, let me pick these steps, put them together. For us to train machine learning model, what we need to do is these steps. Oh, I didn't copy that. Okay, I copy this. All this one is explanation that you see it. So for you to train machine learning model using Scikit-Learn, these are the steps. Import the classifier. We have many classifiers that you want to do. So this is what I'm saying. We have different kind of classifier. Can you see different kind of algorithm that you can use? Or that I showed previously. These ones, you can see SVC, whatsoever, every different of them. When you import this classifier, then create an object. So what we mean by an object, call the classifier here and pass some parameters. There are many parameters that we will learn how to do them. Just assume this is it. Now this is a create an object here, then train the model. Then call the object here, KNN. You can see this is, if you understand how object-oriented programming that we did in Python. So call the object and the method on the object. So this is a fit method that do the training. But what are you going to pass into the fit? The training stuff. That is the xtrain and ytrain. That is two things that you will pass into the fit function. Remember the xtrain and ytrain. So these two things, xtrain and ytrain. So here we will do training. We will train our machine learning with this xtrain and ytrain. That is what you will pass to the fit function. And the fit function is what actually does the training of machine learning. So here we say KNN, fit, you pass it to xtrain and ytrain. So now here we train our machine learning model by running only this one. We train our machine learning model. So here, the training, the parameters that we train are all embedded inside this object KNN. The train everything. So you can see the fit method return the KNN object itself. So we get the string representation or classifier. Now we do training. You even finish training your machine learning model now. You finish training. Now, when we train our machine learning model, now how can we know that our machine learning model, the model learn very well? The next thing after you train my machine model is to do what is called evaluate the model. So here we train the model, and now what we want to do is to evaluate the model. So you see here, let me recap. Basically, the step we want to do to do machine learning model is to prepare your data, frame the problem, prepare your data, process the data, then divide your data into train and test set. When you divide your data into train and test set, the next step is just train the machine learning model. How can you train machine learning model? Using Scikit-Learn, these only steps is to train machine learning model. We will learn when we come several method to do regression or classification. Just import the classifier, create an object with that classifier, then call the method called fit to train the model. In fact, you can even pass, sometimes you don't even need this step. You can create an object and fit the fit at the same time. So here maybe someone can say, okay, I don't need this step. I can do this at one step. In Python, we can do that. We can do this. You create the object and you call the fit method on the object in the step. So here you can see how many steps you train your model. You only one step. For those that we did that know Python, you see this, you create an object, but what it returns, you fit this function on what this object returns. So you can see we can do create the object and also put on the same line. So when we go when we go further, we will just do one steps without dividing into double step. But just for now, let's leave it in this way so that we understand, because this is KNN. This step return KNN. But here we are calling this object into the KNN. So this is the same step we are doing, just repeating it. So right now we train our machine learning model, but we are not sure whether the machine learning model will work well. But the next step is to evaluate it. What do you mean by evaluation? The evaluation, it means we use our test data, right? And try to see whether the machine learning actually works. So let me go on over to the previous steps. So here we divide our data here, remember, into train set, this one, train, we train our model, but we evaluate, we test the performance on this. So what we can do is this, we will give the machine learning this test, and try to see whether he can predict correctly these levels. Given these features, then we can see whether he can tell correctly this level. So this is the next step. So evaluation steps. So for us to do that we also use a single function called predict. This is it. So you can see why predict. Can you see that? So we said KNN, the same object we train here, we do the fit, then we call it KNN.predict X test. Can you see that predict X test? What are we passing in the predict, this section of that we divide? X test. What is X test? This is what we are giving it here. Look at it. We train the machine learning on this. How do we train it? We say, okay, if you see this, this is the correct answer. If you see these features, this is the correct answer. If you see these features, this is correct. We train it. Now, how can we evaluate it? Okay, we'll give it this. We say, okay, do you see this line? Tell us what is the answer here. Do you see this feature? Tell us what is this feature. So it means we will pass predict this X test. Do you understand? So here we pass predict X test. Predict. So you can see we pass predict KNN that predict X test, and it gives us what we call Y predict. Can you see that? Y pred. So let's look at Y pred. So this is a Y pred. So you can see the first one, the machine learning model say the first one is called is iris vesicula. It predicts its iris. So how can we, a question? So let's look at example. Where is our, not this one. Let me show you something. So let's look at our Y that we divided. Okay, this is an example of our Y. Oh, okay, where is the X test? I want to see the X test, not this one. Okay, let me do this. Y test. Y test. Okay, Y test. So what I'm trying to say is this. Just we give the machine learning the whole of this to learn, right? But we predict for it to do prediction to evaluate, we give it this one and try to answer this one. Now let's look at what it answers now in the first instance, in the first example, when we train. When you say, okay, X test, predict, what is it? Y pred, it gives us the answer. Now the first answer is what? Iris vesicula, right? Let's look at our example, our Y test. What is Y test? Can you see the first one in Y test is iris vesicula? Can you see that? It means it predict correctly, but this is not how we try to see whether it is correct. Now it means we did the prediction, but how can we evaluate? We see, try to compare whether this is true prediction, this is true prediction, this is true, or it makes something. We use another function called score. So you call KNN. So you call KNN, you say score, you give it the X test and Y test. Can you see that? You give it X test and Y test. Remember, For prediction, we only give what X test, and it does prediction. We call it KN, and here we call this S test, and Y test we call this one. And this one, when we run it, we can see that our model accuracy is 97%. It means our machine learning model does a good job. So this is basically how you evaluate the model. Don't worry if something is not clear. We have not just started the machine learning. We are just giving the clear picture, big picture of how machine learning works. We will take each step and understand how it works. So we say for this model, the test accuracy is 97, which means we made the right prediction for 97 of the iris in the test set. So under normal assumptions, this means that we can expect our model to be correct 97% of the time of new iris. So it means that when even we get a new data set, it means 97% our model will make a good performance. Yes, so that is how we can evaluate the data. Finally, we can make prediction. So now let's assume that someone just bring some points from our for any different flower. Some bring some point. We want to make prediction on that point. So for example, he said this is the sepal length, this is the sepal width, this is the petal. You can see we have 4 instances, and here we create an array, and we want to do prediction on this one and try to see whether these points are either which flower, what is that. So this is the last point. Here we say, okay, let's create a point. So here we create the samples of given a flower. So this is just an example. Someone, for example, you train your model and someone just give you, okay, this is point particular, this is the length, this is the width. Tell me which flower is that. So we can see we create 4 point, is that correct? And here we have, we call what our function predict. So you can see here, I just create X new, which is a single variable. I create, I need to do the prediction because KNN is already trained. Since it is already trained, you just call the predict function. So here I can predict, and now I can see my prediction here, which is setosa. So this predict that given this futures, these values, then that flower is setosa. So this is actually basically what machine learning steps are. To just summarize what we do today, it's just trying to get the whole picture of what machine learning steps are. So these are just frame the program and get the data, process the model, the data, evaluate the data, make prediction. These are basically, and these are the simple steps to just train and machine learning model. So you can see this is called applied machine learning. You don't need to know the mathematical background. All you need just to use the Scikit-Learn with the function just to do the machine learning and the training. Don't worry if these are not well cleared. When we go, we'll take the details and discuss them. Yeah, so I think for today, this is any question before, any question? Any question? Falalu.
Yes, sir. What I'm saying is that we're representing the features. Does it mean that all objects that we want to maybe extract the features from, must we represent the features into these floating point numbers?
What do you mean by floating point number?
Yes, just like what the measurement, like 5, like
no. Oh, okay, okay. So this measurement, why? So let's look at the example we have when the data was given. So this, what they said is like a botanist, someone just measure the data set, and what happened is this, she wants to do some kind of measurement. So she said, okay, the sepal length is this, sepal width is this, and this. So she wants to predict, given this kind of feature, what is that kind of that? So we know that the measurement of this is in centimeter. So that is why it's in point like 6.7, but it can be any, if it is a single digit, we don't need it to be, this is just an example. The measurement is in centimeter, and this is it. So that is why here we give an example that in like with point for a single number. Yeah, so here also one thing you should know is this. You can see that this array that we can, the NumPy array we did, it's not a single bracket. Can you see that? It's double bracket. Why? Because, okay, let me remove this one bracket and see. So this is NumPy. When we run this, what will be this? Can you see this is one dimension array? Can you see that? But remember, for you to do that, the whole function that you will put into the XNew must have the same dimension with your Y. So it must be by 1 by, because your futures in the train set is 4 futures, right? So that is why here we use this one to make it to be in the same dimension. Can you see that it's 1 by 4? It means this is telling us it's one. We have one instance, but with 4 futures. These are the value of 4 futures. This is not that we made measurement of this single player into a row in a 2-dimensional NumPy array. As a Scikit-Learn, always expect 2-dimensional array for the data. Can you see that? Scikit-Learn expect always 2-dimensional array of the data, because the first one is 1 dimension. So we need to change. If you remember our NumPy, how to change this one, that is how it works. Yeah. I don't know if this makes sense, but don't worry. This is just an example. We'll see detail of it. Any question again? Right. So what we asked last week is for us to watch these sessions and read these chapters. I believe anyone that reads the chapter 1 and 2 of this book, or chapter 1, anybody that read that? Anybody here read that?
Yes, sir.
Well, I read chapter 1.
Of which one?
The introduction to machine learning with Python.
What about this one, APM?
No, Allah, I couldn't.
Yeah, so I will urge you to read this book, chapter 1.
Yes, I will today.
Yes, I want to read it also. Yes, as it's recommended in this one, because you really understand when you read yourself. And I'll urge you, like, don't just read and pass. You need to find effective way to make notes as you read. For example, you read some stuff, just try to note them that you will go back, because you may forget them. So try to make a good reading habit, like, not just read, but get some ways in which if you read, you actually remember them. There is what is called Anki. Anybody knows Anki here? Anki. Anybody know Anki? Anybody know Anki? No one know Anki? Huh? Okay, so this is Anki. Is one of I was using Anki. This is Anki. So what is Anki? Anki is a free and open source flashcard. That is what is called flashcard. So when I used flashcard to practice some concept that I learned. So maybe you can check what is Anki. It's a good stuff that a lot of people around the world are using to actually, because there are a lot of information we learn, right, every day. You are studying machine learning, and there are a lot of concepts. For example, here we come here, we said, okay, these features are called categorical. So what different name? When we okay, let me show you what is called space repetition. Do you know what's called space repetition? Space repetition. So what is space repetition is like there is what is called learning curve, forgetting curve. So as we learn something today, when we learn something today, we will be able to remember it in next tomorrow. But as time passes, in 1 week, 2 weeks, 3 weeks, our chances to remember it diminishes. So this Anki is a kind of flashcard that when you learn something, so for example, today I learned something called future. What is future? You just put it in the Anki. So it will be, it's just like a system of flashcard that you will be reading. At time, it will like remember you to study it, and when it present the stuff to you, for example, and you don't remember it, and you say, no, I don't remember, it will like try to remember you daily. So this is some way, just check it, what is Anki, and try to see it. Just a software you can have on your mobile phone, and you can also watch YouTube videos, how people are using it. So just what I'm trying to say is that this space in machine learning, you need to find an effective way for you to actually try to make your node and some stuff like that. Right. So please try to read this one. This is the reading for the last week, and you didn't do that. And also the reading for tomorrow is this. So we have this and expect to watch this and this, but you didn't read. For this week is to watch this one. So tomorrow, what we do, we continue with chapter 2 of the book, Introduction to Machine Learning with Python. We'll start getting what is really happening in the machine learning. Yeah, any question before we go on? Any question? Right. So I think if there is no question, maybe we can say we meet tomorrow the same time and continue discussion with chapter 2 of the book, Introduction to Machine Learning with Python. If you don't have the book, I share the link where you can download the book, Introduction to Machine Learning with Python, in the Slack channel. You can download it. Also, I share a link to download this book. You can download them. Try to read also chapter 1 and 2 of this Applied Predictive Modeling. It's a good chapter. Yep. So I see you tomorrow. Bye-bye.
Thank you, sir.
Thank you. Bye-bye.